Hey everybody, welcome to Come. We're going to do an example problem using the combined gas law. And in this one, temperature is going to be held constant. So it says a gas has a pressure of 705 mmHg, which is millimeters of mercury, and a volume of 2.10 liters. What will the pressure of a gas sample be at if its volume is decreased to 1.65 liters? Assume that the temperature and amount of gas are both held constant, and it says show all of your work. So first thing I always like to do is write out my variables. So I have P1, V1, P2, V2. Okay. The reason why I didn't write T1 and T2 is because it told me right here, assume that the temperature and the amount of gas, but mainly that the temperature is held constant. If something is held constant, you're not going to use it inside of your calculation. So the first pressure is 705 millimeters of mercury. So 705 mmHg. First volume is 2.10 liters. You're looking for a pressure 2, and then V2 is 1.65 liters. So normally the equation you work with is P1 V1 over T1, and it's equal to P2 V2 over T2. But like I said, pressure is held constant, so you're not actually going to be using those. So really it's just a linear equation there. All you have to do is sub in the things that they gave you in your calculation. So P1 is 705 millimeters of mercury. V1 is 2.10 liters, and that is equal to your P2, which is what you're trying to find, multiplied by 1.65 liters. And I always like to highlight what I'm looking for. Now, what you need to do on the left side, let's clean it up a little bit. So you're going to multiply 705 times 2.10, and you're going to get 1480.5. And don't forget to carry down your units. Millimeters of mercury times liters equals P2 times 1.65 liters. And again, I'm going to highlight that P2 value so I don't lose it. At this point, I just want to get P2 by itself, so I have to divide each side by 1.65 liters. 1.65 liters. When you divide something by itself, it cancels. And you're going to notice on the left side there that liters are going to cancel, and you're going to be left with millimeters of mercury. And that's a way to make sure that you're on the right path because millimeters of mercury is a pressure unit. And when you take 1480.5 divided by 1.65, you're going to get 897.27 millimeters of mercury. And that is your P2.